we're going to be going over graphing rational functions. This is assuming that you already know how to find the asymptotes and the holes. You need to know horizontal asymptotes, vertical asymptotes, holes, and oblique asymptotes. Remember that you also need to know how to factor, solve polynomial equations, and all those things. For this example, you have to graph the rational equation, and I have already provided the asymptotes. So the first one is going to be the horizontal asymptote, and that's y equals 0. So at y equals 0, I'm going to draw a dotted line. So we know that our graph cannot go through that section. And for the vertical asymptote, we have two. We have plus 1/2 and minus 1/2. In this graph, you're going to see that the negative 1/2 and the positive 1/2 is going to create a very small space, but we know that there's a graph in between. So when it comes to graphing this rational function, we need to be paying attention to the left side. We also need to pay attention to the middle and then the right side. To do this, the easiest way to figure out where the graph goes is you're going to look for numbers in the left side and you're going to create a table. Use the equation to plug those numbers in. So you're going to put your x and y coordinates, and you're going to choose two numbers on the left hand side. So you're going to start with, let's go with -4, and we can put -2. Then we also need the numbers in the middle. Because this section is so small, you have to choose numbers between -1/2 and 1/2. You may choose the positive and negative side of, let's go with 1/4, positive 1/4, and then you can do the right side. And I'm going to choose again just 2 and 4. This section, you're not going to do it by hand. Just use a calculator, plug in the numbers, and get all the outputs. We see that the first number at -4 and is giving you -0.12, so we know that it's going to be on this part because it needs to be below the line, and we know that it's going to be a very, very small number. We can just put our number somewhere there, and then at 2 it gets a little bit bigger. So you're going to see that our graph is going to look something like this. As it gets closer to the asymptote, it's going to be going down forever. Now, the middle section is interesting because at -1/4, you have a positive number. And then at positive 1/4, you get a negative number. So that means that this is actually going to cross. So that means that part of it is going to go up and it's going to keep going down on the other side. And lastly, on the right side, you see that the numbers are positive. So that means that it's going to be on the top part. That means that our graph is going to look something like this. So again, what you're trying to do is graph the asymptotes, and then you're going to find numbers in between the domain to find the y values and sketch the graph. In this example, you have one horizontal asymptote, and now you have, again, two vertical asymptotes. So we're going to draw those lines. The first one is at y equals 2. So we're just going to make our horizontal line at y equals 2. And then you're going to do a vertical asymptote at -1. and then another one at 1. And that's because we have a plus or minus 1 as your vertical asymptote. Once again, the only thing that you're going to do is find numbers between the domain. So we need to find numbers on the left hand side. So anywhere less than -1, you cannot use -1. It has to be less than -1. So let's go with -4 and -2 once again. In this case, our area is slightly larger in the middle, so I'm actually going to choose -1/2 and 1/2. And on the right side, I'm going to choose 2 and 4. And just get those numbers from the calculator. If you look at -4 and -2, so we're looking at the left side of the graph, these numbers are positive, but they're above our horizontal asymptote because they're at 0.13, 0.66 above. So we know that our graph is going to look something like this. Almost like an exponential growth. Now the middle section, you have -6, -0.6, -0.6, but that's not going to create a straight line. So in this case, you should be looking at the point in between. So that's going to be 0. And if you plug it into a calculator, you get 0. So that means that we're going to get a parabola going down. And then if you pay attention to the right side, these numbers are getting smaller, but they're also above the horizontal asymptote. So it's going to be like an exponential decay graph. For this problem, you only have one vertical asymptote. So we're only going to be paying attention to the left side and the right side. But you also have a hole. When we create a table, we need to make sure that we don't include the value of the hole. If you do, it's going to give you an error or it's going to say that it's undefined. So we're going to put, again, X and Y. And let's use -5. We can use -2. We can also go back and use 2 and 4. And the numbers that we get for those are going to be -0.5, 0, -4, and -2. If we look at these numbers are increasing. So from left to right, we see that there's going to be a movement going up. But they're still above our horizontal asymptote. So our first number is somewhere here, and our next number is going to be at 0. So it looks something like this. Now, it tells you that there's a hole at 0. So at 0, make sure that you make a mark that there's a hole there. So we know that that value is not included. And if you pay attention to the right side, this is -4. So at 2 and -4, our number is below our horizontal asymptote. And 4 and -2, again, still below. So we're just going to connect the points into something like this. This one, your vertical asymptote is at 2. So again, we're going to create our dotted line at 2. The oblique asymptote is actually a line, and it's going to be a linear equation. As a quick refresher, this is your y-intercept. So we're going to start at 1. And we're going to use this as your slope, rise over run. So you're going to go 1 unit up, 2 units to the right. So from our starting point, we move 1 up, 2 to the right. And you need to connect those points. So we are going to create our slant asymptote like this. And make sure that it goes to both sides. Once again, we're going to choose numbers on the right side and left side of the vertical asymptote. In this case, the numbers are slightly nicer, so we can actually be a little more precise when it comes to graphing. So we know that a -2 is going to be above the oblique asymptote because it's 0.625. And then at 1, we have the y value is at 4. So our graph is going to look something like this. And at 3, we have 0. And at 6, we have 3.375. So it's going to be closer to the oblique asymptote right there. So in this one, you already have your asymptote at x equals 3. You know that you're going to have a hole at -3, and you have your oblique. So we're going to create a table again to the right and left of the vertical asymptote. The x numbers, you choose whatever you want, okay? And based on those numbers, you're going to get a specific y values when you put them in the calculator. So the first one is -1 and 4.5. So we go to -1 and 4.5. So somewhere here. And the next one is 1 and 10. Just going quickly. Then the next number is going to be 4 and -8. And then we have 7 and 5.5. So somewhere here. And now we just need to take a quick sketch of our graph. Now we also have a hole at -3. So at -3, we need to know which number this is approaching. So right there, we're going to create our hole. So somewhere there.